Hello. Happy Friday. Welcome to Deep Dive. I am sound a little weird. I think I mentioned last week I'm kind of on the tail end of feeling a little sick. I was having some pretty gnarly allergies. And I'm feeling a lot better certainly than earlier this week, and I think that I was last week, as I think I mentioned it then as well. So I am feeling better, but I'm still a bit stuffed up, perhaps sound different, and may have to cough. I'll try to mute you, but apologies if I don't make it. What is up, the autograph over on YouTube? Yeah, I think we're ready to get this show on the road. Browser. So first of all, welcome. Thanks to everyone for watching. You are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. This is the Deep Dive, which is weekly live stream where we are working on CircuitPython stuff. The Deep Dive was originally started by Scott, the lead developer of CircuitPython. He is working a reduced schedule right now. He's kind of still on parental leave, working with a brand new, quite brand new at this point anymore, but a new baby. So he's taking care of the new baby and the previous child that he had before as well. So he's not working full time right now, and while he is out, I tend to fill in on the Deep Dive when I can, and so that is what we are here for. If you, again, are new and don't know, this is kind of all centered around the CircuitPython project. You can learn more about it at the main website here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them over here. Oh man, excuse me. And the way these things work, they tend to plug into your computer with a USB cable. It shows up like a thumb drive. You can edit a Python code file on there. And when you save it, it will execute the Python code for you inside the microcontroller, the little computer that's on these devices. It will run that Python code for you, and your code can interface with whatever other hardware bits and bobs you connect to that microcontroller. Some of them are very general, like these Raspberry Pi Picos, which just have a boatload of I/O pins and ways to connect up with other devices. Some of them are more purpose-built, like the Fruit Jam, which is what we're working on today, is a little sort of mini computer or like kind of video game console style device. It's got a bunch of hardware that's built in, like USB ports. There's a hub so they can have 2 ports. There's a HDMI shaped DVI video output right there. There is audio through 3.5mm jack. There's an SD card. There's a Wi-Fi chip. There's some NeoPixels, some buttons. So you can really use this thing to kind of create sort of a Commodore 64 era sort of style personal computer type device, or a little basic video game console type thing. CircuitPython is just one of the ways to program all these different microcontrollers. There are 615 of them right now that support CircuitPython. There are other ways you can program these devices. This is not the only one, but this is the one that we work on here on this channel. Adafruit, I should say, wow, that's a little hard to read. Wait, I gotta scroll past that, I think. CircuitPython is an open source project. Anyone's allowed to use it. Anyone's allowed to put CircuitPython on their microcontrollers. Even if you like manufacture your own microcontroller, you can make it support CircuitPython. You don't have to pay for a license. You don't have to ask permission or do anything like that. It's all open source. Anyone's allowed to use it on their own hardware. And it is made possible by Adafruit. This is their website, adafruit.com. They are a hardware and software company based out of New York. They manufacture CircuitPython devices, CircuitPython microcontrollers like the Fruit Jam I just showed you, as well as many others. They also sell on their website all sorts of other bits and bobs, breakouts, sensors, buttons, lights, all kinds of fun things that you can do with your microcontrollers. So if you would like to help support CircuitPython, and those of us like me who Adafruit pays to work on CircuitPython, one of the easiest ways to do so is purchasing hardware from them at their website, adafruit.com. Thanks to everyone who does that. Also, just thanks if you are watching and don't. That's totally cool too. So today I am jumping right into the latest Fruit Jam project that I'm working on. What is up, by the way, Beautograph? I can't remember if I said hey before or not, but what's up, my friend over in the YouTube? Nice to see you today. Yeah, so latest app, latest program, latest project here is on the Fruit Jam. It is a logic gate simulator. And so I'll start with the easiest one here. I'm going to give you just the quick version of what this is, what it does, and then I'll jump right into the code and work on a few things. So logic gates, obviously, like in electronics, very important in programming. Not so much the symbolization of them in programming, but the concepts transfer over into programming logic as well. And so what we have is a simulator here where there are these little push buttons, virtual push buttons, I call these. So you can click on them. They change between red and green. When they're green, they're considered, on or high or 1. And then there are a bunch of these different gates. So there's a different little symbol in between each one of these things here. So this top left one is the one I started with. It is the AND gate. And so as you may know, whenever both inputs are true, then the output will be true. And we can verify that by testing each input individually. And the output stayed 0 this whole time. But if I do turn them both on, then the output flops over to 1. And then we also have the wires that connect these things. So there's a little wire there running, a line, right? I'm calling it a wire. Obviously, it's just a line on the screen. That is connecting the button to the gate. And then there's also an output wire that is connecting the gate to this thing here, which I call the output panel, which just shows 1 or 0. What is the value that is being fed into that panel? What is up, my friend Yano over on the Discord chat as well. Beata says, I'm going through a couple months worth of cutoffs and flyaway components. Nice. Yeah, I need to do some cleaning up and putting away of components myself. I was noticing earlier today. So that is the AND gate. There is also the NOT gate here, which will, do the opposite. When the input is false, the output is true. When the input is true, the output is false. There is the NAND gate over here. I won't bother explaining all of these, but you can find these all on Wikipedia if you want. There is the XOR gate, I think is what that one is. The XNOR gate, the OR gate down here, and then the NOR gate in the bottom right there. And they all have slightly different functionality. And these are the basic logic building blocks. From these, all the rest of the computers and all of the fun things in technology that we have essentially are built on top of. So I think I will show you very quickly how this works from the code perspective, and then we'll dive in. And I think what I would like to work on is the wire entity. So there are some wires here that connect some of these things up, but it turns out all the wires that are actually here right now are built into the components. There's a little bit of wire here that's built into the virtual push button. There's these wires, which are actually built into the gates, and then there is the output wire, which is also built into the gate, and there's a little part of it that is built into the output panel as well. And when I say built into, I mean both sort of logically from the code's perspective and also visually. Let me actually open a different. Visually, the way this is working. That's going to get fuzzy, though. No, it's actually... Oh, yeah. Yeah, it does. Okay, so you can see here, this is basically what each gate in the code is. This one is the AND gate, and obviously the rest of them are there. But in the code, this whole thing here with the wires and the output, that is all treated as one sort of object in the code. But I have these ones over here, which are just wires. They're meant to not necessarily be, you know, part of a gate or part of the panel or anything else. They're just meant so that you could connect wires to make bigger circuits. And that's kind of the first thing I would like to work on. But like I said, I will kind of show you real quick inside the code. The code at the code.py level is actually really straightforward. So in FruitJam, it's just setting up the display to the smaller resolution. That way stuff gets a little bit bigger. I noticed that it was also refreshing a bit faster on the bigger display. The refresh takes a bit longer. And I wasn't really using the whole screen anyway, so I decided to zoom it in. We may still tweak that at some point. Initialize the mouse, so that's right now, you know, obviously I was mousing around and clicking on those virtual push buttons. So we need to have a mouse for that. This one say a couple of weeks ago, we weren't talking about board mounts. I had mentioned, yeah, Blue Tack, I remember that, mounting putty. I wondered about board clips other than the board edge mounts from Adafruit shop. Link I shared, so I'd follow up. Nice. Yeah, let me open that real quick here. All right. Oh, wait, what is it? I have to highlight it. Yes. Oh wait, no, this is just in the browser, so I can copy? No. No. In the browser it doesn't work, in the app it works. If you right click, then it works. That's what's up. Yeah, thank you for that. This is like a it looks like that probably goes in the mounting holes, and then its little arms kind of can grab on there. Presumably, maybe squeeze it to back it back out. Yeah, that's cool. To pick up a couple of these. How much? They're a couple cents? 70 cents? Nice. Yeah, thank you for that link, by the way. Okay, so we get back to the code here. So get the mouse. We have a main group to show everything in. We'll put that on a display. We have a background group. That's just the gray in the background there that's behind everything. I just used scale so that the bitmap is a lot smaller than the display itself, but it is scaled up to the size of the screen. Have tile grid for that, so that's all background stuff right there. We create this object that's called the workspace, and so logically the workspace is a tile grid that all the rest of these gates and all the rest of these things I'm calling entities go inside of. So that's what the workspace is. We'll look inside it in a minute. It does have a tile grid, though. Like I said, it's like kind of the core conceptual visual part of this app is all built around a tile grid. Well, I'd say a tile grid and tile palette mapper is also very important. So that gets added there, and then you can create these objects. So my first AND gate was literally the first one I made, so you can tell I named it that. AND gate, you give it a location that's in XY coordinates of tiles in the tile grid. So, you know, if you imagine, like, this makes it very easy to visualize. Except it's set to the wrong size. That's weird. That oh, because I'm not in the right thing. In the right one. I opened a different one. There we go. All right, so if you visualize, so these the sprites, the tiles are 24 by 24. So if you imagine this sort of a imaginary grid, right? We can view it here in GIMP because I can draw these grid lines. The same thing is effectively happening here. We have kind of an imaginary grid, and then we can set the tiles from this sprite sheet onto the grid. And these coordinates right here are in tiles. So this would be tile 0, 0. Next to it would be 1, 0. Down from it would be 0, 1, so on and so forth. And so you give it the location, and the way that the location for the gates work is you give it essentially the top left corner of the gate, which is this tile right here, which matches up with 1, 0. You pass in the workspace because internally it's going to add itself to the workspace and take care of some other stuff related to that. We can create the rest of these types of objects the same way. An output panel, we give it a location, we give it the workspace. I have a virtual push button right there. We give it a location, 0, 0. So that's literally this button object right here. Give it a workspace. We give it initial pressed state if we want. I have another button right down there. Same thing. We give it location, workspace, and state. And then once these are created, they get automatically put into the workspace. And whenever workspace.update is called, it will automatically work through all of the logic simulation. So for instance, we can see that by going with these virtual push buttons right here. If we change the first one to initial state true, and I rerun this, now we'll have a green button top left and red button below, and we can see that's on 0 still. And if we change it to true, and I'm changing it in the code here to show that that update is doing. Obviously, I was clicking it before, which also calls update, it turns out. But here we can do it without even clicking anything, right? This is my PC mouse, so I haven't even moved this mouse yet. So now these both start on true. And then because we called update on the workspace after we created all this stuff here, it actually ran the simulation for all of these. So it starts at the end, it works backwards, and it goes and it traces through until it has nailed down the full logical state, and then it will set the output accordingly, change the colors of all the wires and all that fun stuff. And then inside the main loop, it's actually really simple. It's just getting, update the mouse, check if anything was clicked. If anything was clicked, then it just goes and calls workspace.handle mouse click, passes in XY coordinates, and leaves everything else up to the workspace. The workspace will essentially look at all of the entities. It will find the ones that are clickable, which right now that's just the virtual push buttons. And if the place where you clicked is a clickable entity, then it will call handle click on that entity. And the virtual push button has code inside of there that will do the right stuff for it. So let's talk a little bit more about entity, because I keep saying that, and that's the thing I haven't shown yet. Entity basically is just a logical, programming class that represents all these different things. The virtual push button is one entity. This one is another, another copy of the same kind of entity. The AND gate is an entity, and that includes its wire up here, its main body 2. There's actually 2 wide, 2 tiles there for the main body, and the wire down here. Those, what is that, 5 tiles total? 1, 2, 3, 4 tiles total. Those are all part of the AND gate entity, and then the output panel is over there, and it's an entity as well. Entity, the generic one, basically just holds a couple variables, the location, the locations of all the tiles. So I was saying, tile 1, tile 2, tile 3, tile 4. There's 4 tiles for that. This list right here will actually contain all of those XY coordinates for all those tiles that represent, the entity that this class is for. This is the base class, so all of them extend this. So that's the locations. That's the actual tile indexes. Those are the indexes within this sprite sheet right here. And then the type is what it checks so that it can determine whether it's like a clickable entity or an output entity, or there's a few other types. These 2 functions get implemented by the child classes. So they don't do anything by default, but the actual other entities do. So let's look at the output panel first, because this is a good place to start. It has a type, it gets its location from the constructor, workspace gets stored on there. The output entity is a 2x1. So its location is considered, again, top left is always the location that it's considered at. So that's its location there, and then it's got one more to the right. So location and location x plus 1. its tiles are 2 and 3. That's because 0, 1, 2, and 3, the indexes of the two tiles that make up that entity. It has a single input, which is a Boolean. This is an internal variable that will hold the state of the input. We add that entity to the workspace. This is a variable that holds the location of the input entity. So the output panel right here is expecting to get an input from whatever entity would be 1 to the left of it right here. And this is the formal definition of that. It's saying, 1 left of my X. That's where we are expecting to find an output. So like here, this output panel looks 1 to the left, and it's going to find the AND gate entity, and so it's going to link up with that output right there when it does the simulation. Palette mapping is how the wires are turning green and black. I'm not going to dive into all the way how that works because that would take up a bunch more time. But this uses Tile Palette Mapper. I've done a few streams on that in the past. And I will say, if anyone's interested, if you drop me a question in the chat somewhere, I may come back later and dive deeper on that, like maybe on my stream at some point, because I go a bit longer, so we have time to expand a bit further. But basically, really what this is doing is it's changing the color of black to green. If the input 1 is high, it's changing this one from black to green if input 2 is high. And then it's changing that one from black to green if the output is high. This all happens in this sort of concept of using this Tile Palette Mapper mapping to essentially override the default color map here to just replace black with green or vice versa. Well, actually, technically, it's replacing this dark red, this dark green, and this dark blue with either black or green, depending on the state. Apply state mapping, that's just going to apply the mapping that was generated there. Input 1 will give you the value of the internal variable. The input 1 setter, remember, we're on the output panel here, so this will update the internal variable, and then it will apply the state mapping. So once we get a new value, we update the color of the wires, and then we have this update function here, which will get the input entity. So that's going to look at the tile to the left. It's going to see if there's an entity there. If there is, if it's not, if it is none, it will set this to false. It will apply and it will return. If it was not none, then it will get the value from that entity. And that's going to be important, the value. So we'll see that in a minute. It will get that. It will set it to input 1 right there. And then it will apply, which is actually redundant because it's applying right there. So I don't think we need that. And then entity at is actually just calling workspace.entity at. Or sorry, input entity is actually just calling workspace.entity at and then giving the location of that. All right, this one's the push button. Let's look at the gate though. Let's look at the AND gate. The one thing that's important is all the gates actually extend from this 2 input 1 output gate, because it turns out across all the gates, they have very similar behavior, right? They have 2 inputs, they have 1 output. There's a bunch of functions and properties that handle that stuff that are common to all the different gates. And that's what all this stuff is going to be. So input 1, input 2, output, all variables to hold those later on. The location of input 1 entity, the location of input 2, so a property to be able to get the output, a property to be able to get the actual entity by looking it up from the workspace for entity 1 and entity 2, the value of input 1, the value of input 2, and then this again is a parent class, so there will be like an AND gate class that will extend this, and it will implement these. So these are actually left blank, but there is value right here. So I said value, remember that, that's going to be important. So now we're here. Whenever we get the value of an AND gate, what it's going to do is find the two input entities. If they are none, then the value is false, no problem. If they are not none, then we call .value on that input entity. So that is actually going to chain, right? When we call update here, it's going to find this entity, it's going to call value on it, which is then going to find this entity and call value on those. And we could chain the gates together. It will follow that all the way back until it gets to the end of that whole chain, calling value on each one of those entities, which will in turn call value on the other entities that are further, upstream, if you want to think of it that way. So it's kind of like, it feels recursive, but it's not technically, because it's calling value on other objects. But it kind of like recurses its way through all of those entities until it knows the final value of everything. The palette mapping for the 2 input, 1 output gates is all basically the same. So they have this function here that does all of them. Applying is all the same. Okay, here we go. AND gate. So we'll look at this one and then I will jump in to actually start coding. So AND gate extends that 2 input, 1 output as a type, as location. There's the tile locations. I said it was 4 tiles before. Those are the sprite indexes. That's where we add the entity into the workspace. Set up the locations of the input entities. And then we have where a lot of the magic happens, which is right here in the input setters. So input 1 setter, input 2 setter. And here is where we need to apply the rules of the logic gate. So this is an AND gate. So inside of input 1, it says whenever input 1 gets set, we update the Boolean, and then we're going to set the value of output to input 1, the value of input 1, and the value of input 2. Then we will apply the state mapping. So whenever input 1 gets changed, we also update the value of output, and then we also apply the mapping, which will change the wires to be green or black based on whether it's high or low, right? Same thing with input 2. Whenever that gets updated, we apply the logic. We go and say if input 1 is true and input 2 is true, that's what we're going to store in output, and then we apply that. So this is very important that in the input 1 and 2 setters, the property setters, that's where we apply the actual logic from the gate. So to look at like one more, just to give you another example, in the NAND gate right here, same exact concept all the way through, except for here, the logic is different. So instead of this and that, it's now not input 1. So input 1 if it's equal to false, or not input 2 if that's equal to false. So if input 1 is false or input 2 is false, then output will be true. And it will apply the state mapping, and then same thing here. What's up, Ask Patrick W? All right. So I'm not going to go through the rest of the gates. They all basically work the same way. They apply their logic inside the setters. They do their thing. And that makes the rest of the simulation work. What I would like to do, though, is work on a wire entity so that we could maybe, split these things up further to build like a larger thing. Right now, these are kind of like the smallest they can be because they're effectively just test code. They're an output, a gate, and 2 inputs, which just lets me make sure that the gates actually work. But now I'd like to be able to have a wire. I think I'm just going to come in here. I'm going to make a wire entity. I am going to model it, I think, after the... I'm going to model it after the output panel. So type, yeah, we'll just do wire for that. So, and type is totally a custom defined thing, right? Like I just made this concept up. I get to choose what all these are. There's just other spots in the code where it might be like, check the type, and if it's this type, do one thing. If it's that type, do one thing. All right, tile location. So the wire is just going to be a single. It's going to be a 1x1 entity, a single tile's worth of wire. Obviously, you know, if we get it working, you could put another one next to it, but that'll be another entity. We also, the wire inherently has an input and an output, I guess, which means wire is going to be directional. So right now, everything is sort of like inputs on the left, outputs on the right. I think I'm just going to keep it that way. So for the horizontal wire, inputs on the left, outputs on the right. I think that's just how we're going to do it. We'll see if I run into trouble. Or if at some point I have a change of heart, but... So we need the index of this. I happen to know that this is 0, 10, and 20 because this is 10 wide, 10 by 3, which means that this is 19. 19, we have only a single tile index again because this is a 1x1. We do need these to be a list though, or a tuple in this case, so that's what the comma there is for. We will have an input 1 is false. We'll have a, yeah, we can go ahead and do that. But we're also going to have an output, which we will set as false as well for initializing. Input entity location, that's actually just going to be the same. We're taking the entity that's to the left of us. Okay, I think that's basically all we need for initializing. Palette mapping. Yeah, so we really only check one thing here, right? So we're just... this is updating 3 different colors, which we don't actually need to do. We only need to update the green, which I think is index. Have this for my palette so that I don't always have to go back to GIMP. Green is 4, actually. Or that's kind of, is that current? Oh, right, yeah. So I did red is kind of input 1, green I guess I did input 2, so it pains me, but honestly, these should be red instead of green. It totally does not actually matter, so I'm gonna my best to ignore it for now and not actually change it right this second, but all right, so palette 4, if the input is true, we want that to be green, which is going to be 7. I think we want the values from the first one. So green for 7. Oop. Index of that is 7, and then 1 if it's not true. So if the value of input 1 is true, we want to replace index 4 with bright green. If it's false, we want to replace index 4 with 1. That is our palette mapping. This be here. Maybe we should have one more parent class, because I feel like this is basically duplicated in all of them. But I'll worry about that later in a refactoring passover. I actually have done a bunch of refactoring already. Had a bunch more of these duplicated. All right, so input 1 setter on this one actually doesn't... Yeah, there's no logic to apply, right? This would be where we would apply logic, but this is not a gate. It's just a straight up pass through. Let's see. Ask Patrick says, if you're like me and you didn't know anything about Fruit Jam, yeah, it is Raspberry Pi RP2350B based board. Absolutely true. Are they in stock right now? I think there might be. If not, there's definitely more getting made all the time, so they're getting to the point where they're coming back in stock, even if they're not. Yeah, okay, so technically they are out of stock right now, but like I said, there's more being made all the time, so to the point where they're popping back up in the store every week or 2 weeks or a couple of weeks. Okay. So wire, it's not going to have update. Update is really only actually needed for the output entities, like the output panel. And the reason why those have update is because that's where the code starts. So whenever we call update on the whole workspace, it goes and it finds all the outputs and it calls update on them, and that's what starts the chain of calling value on everything else. And we always start at the end. We always start at the outputs. So the wires, they're not going to have update because they don't have any logic. They simply just, they'll be part of the rest of the chain. They will have a value though. So we'll make a value, and that is just going to return output. That's just a straight up pass through. And in fact, actually, one more thing we need to do here. Realistically, I guess technically we don't even really need output to be a separate variable from input. But I think I'm going to do it anyway. Just to make it sort of the same as the rest of them. But like, we totally could just set input 1. Oh, I shouldn't set this to false though. Value. We totally could just set input 1 and return input 1. But I'll keep output just so the code is actually the same between them. Input entity, that's going to get the entity at the entity location. Okay. And then this itself, you know, the wire will be an input entity for whatever comes to its right. Okay. So I think that is maybe all we need for a basic wire. I'm going to get rid of the rest of this stuff for now, just so we can have some more room. Actually, let me keep this OR gate down here, and let's get rid of everything besides that. Oh. All right, 1 second. Okay, there we go. So let's now scooch our buttons over further. So we have those virtual push buttons. Let's scooch those further to the left. All right, there we go. So now we have one button that's on. We can see it has a little tick of green wire there. We have one button that's off. It has a little tick of black wire there. And then we have nothing in between, right? There's no connection. Therefore, our OR gate has 2 falses and outputs false. So now that wire, we should be able to put in the middle. You know what? Actually, one thing before we do this, this needs to be horizontal wire, right? Because we have a vertical one as well. So let's call this horizontal wire. That's the only thing to change that. So we do this, so then we have 2 V buttons, and we will put a H wire 1. So that'll be 4-6 workspace. Import that, and let's just do 1 and see if it works. Okay, it is drawing the line at least. Will it? I don't sure if it will turn. It doesn't turn. I think if that doesn't work because it's broken, or if that doesn't work because we actually need both wires. It's probably broken though. Mm-hmm. Definitely broken. Okay, so let's see here. Going wrong. All right, so let's just start at the end of the chain here. So I kind of like to logically just go through the code. So update, or rather output panel.update is what's going to get called. This is the output panel, and update's going to get called on it. It's going to try to find its input entity, which should be the OR gate. Could buy it. I think it will print the type. If not, we could make. Okay, yeah, input entity is the OR gate. That's fine. It is not none, so it's not going to do this stuff. It's going to get the value of the input entity. So from the OR gate, which actually calls value on its parent class. And, well, let's just say gate dot value. Make sure those are the wires. All right, so yeah, gate dot value. Input 1 entity is a horizontal wire. Input 2 entity is a horizontal wire. So we have our objects. We would have then called value on those. A horizontal wire dot value should return the output. Okay, I see the problem. So we've never set the input. Right. Never set the input. Okay. Let me look at the virtual push button. How does value work on it? Just returns pressed state. I think, so here we need to do more than this. We need to use this? Uses this. We need to get the input entity. We need to get the input entity's value. Yeah. Basically, in fact, we really basically need something kind of like what's in here. Obviously, we only have one input, so it's a little bit different, but one entity. So actually, we just have. I am gonna. And then we'll say if that's none. That gets to false. Else. 1 equals input see that value. There we go. So now value is actually going to get the entity to our left, get its value, so it should continue the chain. And that's going to, inside of this setter, that's going to update output, which is the closest thing we have to logic for the wire, and then that will return. I think that should work. Mm. There we go. Nice. Sweet. Okay, cool. Let's make sure that 2 wires in a row works. I don't think it wouldn't, but let's turn off some of the prints. Biggest offender is going to be in here. We need 3 and 4, not 4 and 5. There we go. Okay, cool. Totally. Horizontal wire is working. Let's make vertical wire. This is basically going to be the same. The only real difference here, I think, is just going to be the input entity location. I'm going to copy paste all of this, but eventually I will actually probably make a wire class that these will extend and just update the entity location. Let's get it to work first, and then I'll do that. Perhaps I'll do it tomorrow or sometime, but we'll see. So vertical wire is a wire. It will have a... Oh, okay. So, yeah, if we do that superclass I was talking about, we'll have to also update the tile index. So we want vertical here. Oh, actually, another thing I need to do, which gives me a chance to change these. So I'm going to do it. I'm going to change these to red because red is meant to be input 1, and these are wires. They only have 1 input, so I'm considering it input 1, so it should have been red. Consider it wrong. I didn't do it red. That red, and then this red, but actually this one is also in need of something else because I basically made these gates wider at one point. They used to be 1 by 1, and it was really hard to cram all the stuff for the what is that? The XNOR gate. It was really hard with 24 pixels to make all of the features of that. The little ball at the end, the line there, the curvy bit there, the sort of pointy curvy bit there, which is actually just pointy angled here. So I expanded these to be 2 tiles each, and when I did that, I moved where this wire connection here was, and this actually needs to line up with it. I moved it over by 2 pixels. Oh, okay, I can't. Zero. Why that does? Oh. I should not be modifying this in the bitmap. Have an itself or a sprite sheet GIMP. That's really what I should be modifying. Okay. So it's copy the updated sprites to the device. So wire, we need to update this palette mapping because now it needs to be red instead of green. This means we need to change that index. That should be it, I think. Okay, so vertical wire, it's not 19, it's actually 9 because it's on the next row up. The input entity location, I'm going to say, is above. So that's going to be -1y instead of -1x. And everything else, I think, should just be the same and basically work. So now let's say we want to move this virtual push button up one. Here, 5 instead of 6. Actually, yeah. Oh, right. Because I copy pasted, I actually have 2 palette mappings that need to be fixed. Yeah, so you can see in the sprite sheet, the dark red, the dark green, and the dark blue are like placeholders. They're never intended to actually be seen in the interface. They're just there in the sprite as a index in the palette that we can override with the mapper. Okay, so now we have that up there. So we basically need our vertical wire here, and we need all of our horizontal wires to scooch up by 1. Well, our 2 wires to scooch up by 1. So 5 and what? Okay, right. Because we added them. Yeah. Okay, so that we come up by 1 here and up by 1 here. But made those in a weird order and threw myself off there. There we go. Okay, so now this is connected to the button. Ooh. Right. Wait, what? Ah, right. Yeah. Forgot about that. So yeah, because the wire here actually goes to the left. So the vertical wire, it would actually technically need to connect like in place of this block here. But that is actually not really possible. Because that block is actually part of the entity, and that concept of this tile over here being the input entity location is hard-coded. So we cannot do that this way. We would actually need a wire that goes over and then up. 1, 2, 3, 4 blanks, and then 2. Actually need this wire. Didn't even test the vertical wire yet. Now we actually need a... call it a top right wire? Don't have a better name queued up. We only have a few minutes left, and I don't want to spend all of it trying to think of a name. Tiles, that is index 1. Wait a minute. Oh, yeah, that's what we need. It's like, am I... We have tile index 1, input 1, blah, 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 this. Input entity location. So this is above. Which is actually the same as that. Okay. I'm going to turn those off for now, just so we're working with only the top row. Okay. And we actually need to scoot that back again, because now we have an extra... turn. Need to scoot both of those left again. Then we should be ready to insert our top right wire, the 90-degree turn, and vertical. So this is to the right of the wire there, and it's down. I don't think I ever updated sprites again after I saved it, if I even saved it. There we go. Okay, so now we have the right turn. But we actually have the next problem now, which is we don't have a left turn. And we still would have to actually go up again if we wanted to test the vertical. There. So now we could have a vertical there. Which is above this. There we go. But we still would need the left turn. We would need the bottom left wire. Instead of top. I'll make this one, see if it works. If it doesn't, I'll try briefly to fix it. That is basically gonna do it for stream. Wait, this is go left. Erase the there we go. This, export this. Update the sprite sheet this time. Make one more wire. This is, I'm just going to copy horizontal because all of the same. Be 19, it will be, that's 9, this would be 8. Oh, you know what? I should merge this down. I don't know if that matters for this, but I am just going to redo this just in case. I don't think it actually matters. Tile is 8, and then input entity is to the left. Yeah. That would be up again one more. Oop, that's not up. It's left. Looks like a challenge project, lots of little details. Way to go. Yeah, thank you. It's been a lot of fun to work on for sure. I will say I'm consistently kind of shocked by the things that, whoa, okay, we messed that up. Oh, I was using that for empty. That's empty, actually. We can't put this here. Good, but I have to go change it. Just gonna move this. I think the why it does. Update this, and then it's actually now not 8 but 18. There we go. That's better. So, does it actually work? It does. Look at that. Nice. Oop, I double clicked. Look at that. All right, so now you can actually make longer wires. It's a little awkward here how you have to over and then up. Yeah. It's a little awkward. Yeah, I'll have to think about whether I want to keep it that way or not. Oh, we already have this tile. I literally just recreated this. We could have just used index 0. There's maybe an argument to be made that this tile and this tile should not be part of one big entity for the gates like it is now. it would be more flexible if this were not part of the entity, and then you could of course connect with that wire if that's what you wanted to use, but you could also connect with just a vertical line to go further up. I don't know though. I don't know if I want to change that, because I think it, like, whenever you make a gate, I think it's very likely that you're gonna want to make two inputs to the gate, right? So I would like to minimize that. So I want it to be where you can just make the gate and make the button right next to it, and the button is automatically hooked up to the gate. If you had to explicitly make the gate and make the wire and make the button like that and make the wire in the middle, I don't like, because you'd have to make two of them as well. So then you need 3 different objects just to use your gate. Something to think about though. It would be more flexible if you could go vertical there, and it totally could work that way, but I don't like having to make extra wires from the code perspective. So I don't know for sure if I'll change that, or maybe I'll come up with a better idea for it. But in the meantime, we did manage to implement a couple of new, well, all of the wires, essentially, vertical, horizontal, and then a couple of those turns in order to be able to test it. And that is all working well, it looks like. Super cool. All right, that is going to do it for tonight. I just realized that the YouTube chat was actually cut off, so my apologies for that, but that's the rest of the YouTube message. I think I read it out earlier when it came through, so yeah, that is it for tonight. Thanks everyone for watching. I will be back tomorrow over on my own channel to stream again some CircuitPython, so that'll be tomorrow the 4th. That's at 10 a.m. Central Time. 10 a.m. Central Time is when I stream on Saturdays over on my channel. I will be back for the deep dive next week, but I will say right now I am actually going to be off on the deep dive for the 17th, so probably there will be no deep dive on the 17th, and actually there will be no stream for me on Saturday the 18th as well. I'll be off these days, so next week should be normal. Deep dive on Friday, 2 p.m. Pacific, 4 p.m. Central, 5 p.m. Eastern. My stream next week, Saturday, should be there, 10 a.m. Central, but the following week, 17th and 18th, will be off for me, so no stream on Friday or Saturday. Thanks everyone for watching. Hope you all have a good rest of your Friday night and a good weekend.